I asked you to try the rational inequality on the right, the difference there, the two rational quantities. If you got stuck, if you got to a point where you weren't sure if you're doing it right, or if you just want to see what the answers were supposed to be, you can watch this video. If you think you got it, fast forward to the end, see if you got the right answer. Otherwise, watch it in its entirety. I'm going to go over to the document camera. So here's our inequality. If we're going to subtract these, we need to get a common denominator. So I'm going to multiply the first term by the denominator of the second term, again, the denominator and the numerator. And we multiply the second term, plus 2 by each other, basically. Multiply those denominators by each other. There we go. The denominator then is going to be x plus 3, x plus 2, that. The numerator, if I distribute through the parentheses here, I'm going to get 4x plus 12. I'm gonna bring this negative along with this 3 here. So I'm going to change this to plus negative. Or you can always add the opposite if you're subtracting. And I'm going to distribute that negative 3 through. So minus 3x minus 6. Be careful of that. If you just distribute the 3 through, that minus sign still needs to get distributed to everything in this numerator. Combining like terms, so I've got 4x plus 12 minus 3x minus 6. So in that numerator, I just get x plus 6 all over x plus 3, x plus 2, greater than 0. So I've simplified that down. I've combined those two terms together. Now I need to figure out what values for x would give me a positive result, an answer greater than 0. So this is where I'm going to look at when x will be 0. I want it to be bigger than 0, but I want to look at when x, or when this will be exactly 0. So I've got x plus 6, so I'm looking at when x equals negative 6. We've got x plus 3, so I'm looking at when x equals negative 3, and x plus 2, so x equals negative 2. I'm looking at all those 0 points for these three kind of pieces of that inequality there. So now there's 3 of them. All the other ones we've had have had 2. The method, the way that we did it with these double line graphs works if we have 3 as well, or 4 or 5 or 6. The method is the same. And so even though it's a little bit more difficult and you maybe weren't expecting it, it does work with multiple points. Okay. Everything from there works the same as well. We want to know when this will be bigger than 0 or less than 0, positive or negative. And so it's still going to work where to the right is positive, to the left is negative for negative 2. To the right is positive, to the left is negative, and to the right of negative 6 is positive. There we go. To the left is negative. So that kind of staircase effect still happens where 3, 4, 5, doesn't matter how many terms. Here is where it gets a little bit more difficult, though, because we want to have this quotient, the division here, to be greater than 0. So I need the numerator and the denominator to either both be positive or the numerator and the denominator to both be negative. So I'm looking at when will x plus 6 be positive? Well, x plus 6 will be positive all over here. And when will the product of these two be positive? So when will x plus 3 times x plus 2 be positive? So I'm going to ignore the bottom line here for a minute, where the top line was the negative 2, the middle line was the negative 3, the bottom line here is the negative 6. So ignore that for a minute. I'm asking, when will the product of these two be positive? Well, a positive divided by a positive times a positive, because these are being multiplied here. Positive times a positive is positive, and a positive divided by a positive will be positive. So if I choose any number greater than negative 2, all of these will be positive, and a positive divided by a positive will be greater than 0. Let's look at the next one. Again, I'm going to ignore the numerator for a minute. I'm just going to look at these two terms. I'm going to say a negative times a positive is negative, and a positive divided by a negative is negative. I don't want a negative. I want a number greater than 0, so that will not work. Let's keep going. Again, I'll ignore that and say for these two, the product A negative times a negative is positive, so this will actually be positive. And a positive divided by a positive will be positive, will be greater than 0. So any number between -6 and -3 will actually give me a positive result, because -4 plus 3 is -1, -4 plus 2 is -2, but -2 times -1 is a positive 2, and -4 plus 6 is a positive 2, positive, yep, it's going to be positive. The last one is not going to work because negative times a negative will be positive, and a negative divided by a positive will be negative. That's a lot of negatives and positives. I'm very positive that it was a lot of negatives and positives. So I hope you were able to follow what I was saying with all those minuses and pluses. So really, these are my two areas where I'm going to get solutions. This graph is going to look a little bit different than our other graphs. So my final solution then, any number in between -6 and -3 will work. One thing I will comment on, I didn't have to worry so much about excluded values here because there was no equal sign. If this was greater than or equal to 0, I would have to be cautious of open circles versus closed circles. They're all going to be open because I just want greater than 0. And anything greater than -2 will work. So my solution would be that -6 is less than x is less than -3. Any number in between -6 and -3 will work, or if -2 is less than x, if x is greater than -2. So we've got kind of a combination here of an and an or. I've got my graph, and I've got my solution. That was kind of a weird one because we had those 3 different terms to work with, but the method still works the same.